Now, let's extract the information. We have point A has coordinates 15h feet, C has coordinates 0, 3 feet, AY is minus 32.2 foot per second squared. We know AX is equal to 0. Vy at C is 48 sine of 40 foot per second. Vx at C is 48 cosine 40 foot per second. So we will now write the governing equation. I'll just go in systematic order, even though you can start with the y equation, but I'll just start with the x equation. And the governing principle is x at A is the destination, is x at C plus Vxc times t. So this implies that putting in the coordinates from equation 1 and also for information from 2, so using 1 and 2, I write that x at A is equal to 15 units feet. You can put this at least one time. Must equal x at C, we know, is 0 plus 48 cosine of 40 degrees foot per second multiplied by t. You'll usually see me put an asterisk or a star by this equation here. And just I pause for a while, just a little while, to make sure that my units match. So if velocity is or speed is foot per second, that means I must have a time here, seconds, so that my units will balance out and I'll have feet on both sides. But now if I look at this equation, remember what we want is h. So if I look at this equation, what I get is t is equal to 15 over 48 cosine 40 degrees, and the units, of course, will be seconds. And this I'll call equation 4. So now let me proceed to the next equation. And so for the y direction, I'll write that y at A is y at C plus Vy at C times t plus a half A sub y t squared. I'll call this equation number 5. Substituting the information from 1 and 2, y at A is h, y at C is 3 units once feet, and I have plus 48 sine of 40 degrees. Of course, this will be foot per second multiplied by t, and minus 16.1, that is 32.2 divided by 2 foot per second squared. Therefore, I should have a t squared here. So I'll call this equation number 6. Once more, before I move on to the next equation, I'm going to check that my units balance. So if I have time in seconds, here I'll have feet. If I have time in seconds squared here, I'll also have feet. Solving equation 4 and 6, we find that the answers t for this particular problem is 0.408 seconds, and y, which is what we wanted, the h is equal to 12.91 feet. So that would be the solution, or the answers